To begin, I'm going to open up our Learn site at learn.hashicorp.com and navigate to the tutorial we'll be following today. I'll be using this jump section here to navigate. And I'm going to go up to our architecture overview. Before we get into the details of how to use Packer and Terraform to create a golden image pipeline, let's go over what a golden image is and why teams use it. A golden image is a base image on top of which development teams can add their applications. They typically include common system or application dependencies, security patches, and tools to log and monitor application. This provides two major benefits. One, for developers, they won't need to worry about securing patches or configuring things like logging and monitoring agents. They can focus on just writing the application. And two, the operations and security teams know that any applications built on top of the golden image are secure and can be monitored easily. Traditionally, those operations and security teams are the ones that handle the creation and circulation of images to developers. This process can be manual and time-consuming, though, involving cross-referencing of spreadsheets, emailing developers, and updating build configuration files. This might only be a small update to one file, but that can quickly balloon to become tedious and time-consuming if there are hundreds or thousands of applications and a pull request process around each change. That is where the HCP Packer registry comes in. It is a service that tracks image metadata and consistently provides the desired image automatically through Packer and Terraform integrations. Instead of a literal image ID that needs to be updated each time a new one is created, the configuration files use a reference to the HCP Packer registry using a bucket and channel name, and the service takes care of returning the desired image ID. This means there's no more updating build files each time a new golden image is created. HCP Packer run task integration with Terraform Cloud adds one more layer of control in this process. If an image becomes outdated, you can revoke it to prevent consumers from accessing its metadata and using it to build artifacts. In this workshop, I'll create a golden image pipeline that emulates a typical image creation process. I'll build an Amazon machine image with Packer for the golden image, then an application with that golden image as a base, and finally deploy the application with Terraform, where our run task integration will check whether an image is revoked during the plan stage. We'll get a chance to see it both succeed and fail. Now, for the sake of time, a few of the environment preparation steps of this tutorial have already been completed, and I'll make sure to point those out. Please be aware, however, that the entire process is available on our Learn site, so you can take a close look at all of the details of what I'll be doing today. And before we begin, we're going to take a look at our prerequisites that will be needed for this tutorial. And I will go through this quickly, but again, all of these details can be found on the tutorial. We're going to need Packer installed locally, Terraform installed locally, a Terraform cloud account with a team and governance plan with workspace admin permissions, an HCP account, and an HCP Packer registry with plus tier membership. If you don't have a plus tier, that's okay. We do have free trial credits available that you can use to try this out yourself. And we'll finally need an AWS account with credentials set as local environment variables. So the first step to this process is to clone our example repository, which I have already done. And if I click on my terminal, you can see that I'm located here within the directory that I've cloned. Next, we will talk about the overview of our scenario that we're going to be going through today. This diagram shows the different components and how they interact with each other. The Loki Grafana instance will act as both our log aggregation and visualization tool with Loki, running on port 3100 and Grafana running on port 3000. The other two instances are running the HashiCorp's example application, one in the US East 2 region and another in the US West 2 region. The application consists of an API and a database, each running in a separate Docker container. The Loki Docker plugin and Promtail will work together to collect the container logs and send them to the Loki instance running on port 3100. This is where we want to get to, so let's take a look at how we'll get there. I scroll down to this diagram. This illustrates the pipeline I'm going to create and the flow of data between the different components. On the left side, I see the individual template files that are read by Packer when I do a Packer build command. During that build, Packer publishes an AMI to AWS and metadata about it to the HCP Packer registry. I then see that the information is passed to the main.tf configuration file and read by Terraform to deploy the EC2 instances in AWS. The Packer templates and the Terraform configuration all reference attributes from the Packer registry that correspond to those specific builds. So that's where we want to get to, and there's a few steps that will need to be done to prepare your environment for this tutorial. And like I said, most of these I've already completed today, so I'll just give you a quick overview of what needs to happen. The first is generating an SSH key, and Terraform will use this key to securely connect to the instances. I've already done that, so I won't do it again here. And since we'll be running this demonstration using Terraform Cloud, the next thing that will need to be done is to create an environment variable to make sure that we are using the correct organization. This export command there. The next command will be to run a Terraform login command, which will allow us to complete our Terraform runs within the cloud backend. Next, an HCP service principal is necessary for Packer and Terraform to communicate with the HCP Packer registry. This has already been created, but I'll show you where this is done. If I click into my HCP portal and select my organization here at the top, which I already have, if I scroll down here to the left on access control, IAM, and service principals, I've already created this service principal here, and I've generated a key for it, but you would click that button there to generate a key for yourself. Finally, with those variables in place, you would create your environment variables on your command prompt. I've already done this, and I've generated a little output here. I've got my HCP client secret and ID and my AWS secret access values there. I've redacted the actual values for secrets, but they are present in my environment variables. Next, I'll set up our Terraform Cloud run task integration. Run tasks allow you to directly integrate third-party tools and services at certain stages in the Terraform Cloud run cycle. When triggered, a task sends an API payload to the external service, and this payload contains a collection of run-related information, including a callback URL that the service uses to respond to Terraform Cloud with a pass or failed status. Terraform Cloud uses this status response to determine if a run should proceed based on the run task's enforcement settings that have been configured for the workspace. So to gather some information for that, here within our HCP Packer portal, I'm going to click on Packer and integrate with Terraform Cloud. These values will be necessary to create the run task. Just leave that up while we click on Terraform Cloud. Like I said, I've already created this run task, but the values that you will use are directly from that HCP portal, given it the name of HCP Packer. I've copied the endpoint URL and HMAC key. The endpoint URL is a unique HCP Packer URL specific to your HCP organization and HCP Packer registry. The Terraform Cloud run task will send that payload to this URL for image validation. Okay, so I've got my run task in place. The next step will be to deploy and build a Loki image. This is something I've already done to save time, and we'll discuss some of its configuration code later during a longer build process. As part of that process to build the Loki image, there is a step where a fingerprint needs to be generated. The fingerprint is a unique value that is necessary is used as a unique identifier for the build iteration. By default, this is unset, but Packer will use the head get hash of the template file as the fingerprint. But if your template isn't under version control, or you're in a scenario where multiple people might be using the same Git version and building to the same organization and bucket, you can set it manually, which is what we have done here. Okay, so with our Loki image built, I'm going to browse back into Packer, where you can see that we've got this Loki image. I can see a list of buckets that are available, and this one is called learn.packer.hcp Loki image. Buckets are the top level items in the HCP Packer registry and map to the build block from our template file. And I can see the overview page for this bucket and a description and labels from our template file. If I click on iterations, I can see the metadata published to the bucket for the build that was completed earlier. Next, I'll create a channel for this Loki image. Channels are kind of like a tag or pointer that reference a specific build iteration. And that iteration contains specific images, their IDs, and location in different registries. In our case, it points to AMIs in AWS. So to create a new channel, I'll simply click on this. I'm going to name it production and choose our latest iteration. Now that I have our Loki image built and channel set up in the Packer registry, I can move to our Terraform directory and deploy the instance that will host this Loki image. So I'm going to browse to Terraform, and I've already run my Terraform login. So at this point, I'm just going to run Terraform inits. Okay. Now, part of the process that takes place during the Terraform init command is actually creating the workspace that is defined in our Terraform configuration. And the next step that we'll need to do is actually set our variables in the workspace for our AWS key, AWS secret access, and our HCP client environment variables that I showed you earlier. So now I'll click on workspaces, learn HCP Packer golden image variables, and I've already got those set right here. The next step that we'll need to do is to enable the run task in our workspace settings. We showed it earlier at an organization level, but it will need to be created here in order to have an effect. We can see that it's available for use. If I click on it there and set this to mandatory, this will require that the run task needs to pass in order for the plan to complete. If it fails, the run will be halted and it will not be able to resume until we fix that issue. So now with the run task in place and our environment variables set, we can run Terraform apply -auto approve. The auto approve option will allow me to just let the run proceed at its own pace without having to tell it to proceed. So while I wait for the Terraform to provision this instance, I can review a bit of the Terraform configuration. I won't go over everything in detail here, but there are a few things I'd like to point out. Just shrink that down a bit. So there are a few files here. One is vpc.tf and securitygroups.tf. These will set up the network infrastructure for the two regions that I'll deploy our Loki and HashiCorp instances into. In main.tf, we are defining two data objects that are responsible for retrieving and storing the build iteration and image data from the Packer registry. Notice how here at line 3, HCP image Packer iteration is providing a bucket name and channel as variables. Those variables are being defined here in our variables file. And that is the production name that we provided to those channels earlier within the HCP Packer registry. The registry will provide the iteration to the HCP Packer iteration data object that I assigned the production channel. The other data object, HCP Packer image, then references the iteration returned by the registry in that data object. The image object also provides the bucket name, a cloud provider, value, and a region. And like we saw earlier, all of that data is available here within our HCP Packer registry. Looks like it's going to make me sign back in. Check back on our run task here, still going. And here in the output of the Terraform run, you can see the results of the run task that has been configured. In this case, HCP Packer, and it has passed. The data source and the resource image validation were both scanned and all resources are compliant. And our overall result there is that it has passed. Give this a little bit more time to finish the Terraform configuration while we're waiting. And within main.tf, if I continue to scroll down to our AWS instance called Loki, I can see that instead of a literal AMI ID, the configuration is referencing the image data object and ID that it returns as part of the communication with Packer registry. So Packer and Terraform will work together to get the values that are needed in order to create the proper configuration. Now that Terraform is done, I could visit this Loki IP value in our output and see the Grafana interface. We'll come back to that later. With Loki up and running, I can use its IP address in our golden image configuration files, one for the Docker daemon and the other for Promtail. Adding the Loki address to the golden image means that any application built on top of it will automatically send logs to our running Loki instance. In this case, I just configured it for Docker applications because that's how HashiCorp runs, but the Promtail agent can be configured to ship to logs from any location in the instance. We are going to use a sed command that will replace our placeholder Toki Loki URL with value output by Terraform. I'm going to run it once for the Docker configuration file and again for the Promtail. Copy this output here. Oops. This is going to update the Docker daemon.json file. Then I have one more command that I'm going to copy here to update the promtail.yaml file. Next, I'll move into our golden directory, where we are going to run another fingerprint export command so we can ensure that our iteration has unique value. And then I'm going to run Packer init and Packer build. We'll make sure that this build starts. There we go. And this is creating our golden image. While this builds, I'm going to review some of the code in our source directory for this image. Earlier, I ran the Loki image build configuration, and so we'll talk a little bit about that. But here in my file browser, I've got 4 main directories that I will be working with today. Loki, Golden, HashiCorp, each contain configuration files, scripts, and a Packer template for building their respective images. The Terraform, like we looked at earlier, contains a configuration for deploying instances and other resources. So within Loki, which is what I already did, I'll just talk a little bit about what that image build entailed. The Loki setup.sh file creates and configures the Terraform user, the SSH key, and installs Loki. The start Loki Grafana sh starts Loki as a system process in the background and Grafana as a Docker container. Next, we have loki.pkr.hcl. And by the way, as of version 1.70, HCL2 is the preferred way to write Packer templates. You can use the HCL2 upgrade command to transition your existing Packer JSON template to HCL2. This will enable you to preserve your existing workflows while leveraging HCL2's advanced features like variable interpolation and configuration composability. The Loki pkr.hcl2 is the Packer template that ties all of these other files together. Here I can see that it creates a Loki image from an Ubuntu 20.04 base image, and it will add the necessary configuration files and scripts and commits that information to the HCP Packer registry. Okay, we can see that our build is still going in the background. So while we are waiting for that, I'll go ahead and review some of the golden code. Actually, while we're waiting here, Rob, this might be a good time to see if we've had any questions come through that our TAs have had a chance to answer.
Absolutely. There was a question about fingerprints. You mentioned the fingerprint earlier on. So the question was, what exactly is the fingerprint and what's its purpose here? I don't know if you want to add some color to it. Our TAs have actually answered that one there. I can kind of read that out as well.
You know what? I think our TAs have could be considered the experts on this matter. So if they provided some information, let's go ahead and see what they have to say.
Fantastic. So the fingerprint, it's supposed to help with kind of verifying that the image is authentic, right? It's not any rogue changes haven't happened to it. Also, it's kind of like a git commit SHA, so it helps identify the configuration changes apply during an iteration and what information you can kind of look back at in the git history to find the changes that are applied there. So yeah, that's pretty much the fingerprint. I guess we've got time for one more, have we?
Yeah, let's do one more, and then I can continue on to some other code here.
Okay. There is a question about one-click TFC integrations. Let's go into that one. So do you know whether HCP Packer integration with Terraform Cloud will ever be one-click? Currently, we have to copy over an endpoint, HMAC, etc. And our wonderful TAs, again, have provided us with some information here. The HCP Packer team is continuously working on improving HCP Packer and Terraform Cloud integration, and we love hearing our customers' feedback to help us identify key improvements to our usability. Our goal here is to make integration between Terraform Cloud and HCP Packer as easy as possible. We recommend keeping an eye on the HCP changelog, which I'll get our wonderful TAs to drop a link for that in the chat. But in that changelog, you should see things about new features. And Dane, do we have time for one more?
Yeah, let's do it.
Absolutely. So we have a question here. So how or why is HCP Packer image usage different from using an AMI regex in the AMI name and latest option in Terraform during EC2 creation?
That is an excellent question. I want to make sure that our answers are as detailed and correct as possible. So I'll see if perhaps our TAs could add some enlighten us a bit on that one, and maybe we can return to it during one of the later wait processes in the tutorial.
Awesome. How are we getting on with our build?
Okay, it looks like we are still waiting for the build to complete. So while that's taking place, I can go over some of the additional code that we are currently using in our golden image build. So first up in our audit rules file, this is a collection of rules that are used by Audit D to secure the Docker daemon that will be running on the images that we deploy. Our Docker daemon.json is the configuration file for Docker and contains a reference to the Loki images URL. This is what we updated earlier with that sed command. If we had looked at this earlier, there would have been a Loki URL placeholder, but we've given it an actual IP address now. Promtail.yaml is the configuration file for Promtail and also contained a reference to Loki that we updated with the actual IP address. Setup.sh does the same setup that we saw in the Loki configuration code. But this one will also install Docker, Audit D, and Docker Compose to the golden image. Setup-promtail-sh installs and configures Promtail and the Loki Docker plugin for retrieving and sending logs to Loki. Run-promtail.sh will run Promtail in the background. On golden.pkr.hcl is the Packer template that functions similar to the Loki one that we looked at earlier. One thing to point out here are the tags in the source attribute. Let me just scroll to them. Let's see. Decent pile of code here. Snapshot tags there. Those are metadata that are applied to the AMI in any disk images. Okay, looks like our build is still going. So I guess, Rob, we can check back to see if any other further questions have come through while waiting for this.
Sure, we have another one here. Can you only update the iteration a channel points to manually? or is there a way to configure a channel to always use the latest image?
Have our TAs had a chance to weigh in on that one?
I don't believe so, no.
Okay, perfect. Maybe we can get their expertise here to ensure that we have the best information. We will see a little bit of the iteration options that we have later as we get a little bit further into the tutorial here.
There is actually a similar question which the TAs have weighed in on, so it might partially answer that as well. The question was, can you codify the creation of a channel and or assignment of an iteration to a channel in the Packer configuration? Again, our wonderful TAs have answered. Currently, it is only possible to manually assign an iteration to a channel. Some users have created their own scripts to auto-promote iterations to channels using HCP Packer API. And we have an API reference as well, which we'll drop in the chat as well.
Perfect. I do think the API does have additional options there that are not available through the UI or the command line. So that'd be a good thing to try out for them.
Awesome. Let's see if we can dig up another one here. So does HC Packer Plus tier add any other benefits like RBAC or team management? The short answer to that is no. The Plus tier adds advanced image compliance check with TFC integration and the ability to schedule an iteration revocation. So yeah, so that's kind of what you're getting with the Plus tier. I guess our build is still going, isn't it?
Yeah, it's still going. This is the long one that is going to give us some time here to answer some questions. So I think if there's any questions that the TAs have weighed in on, we should just keep going here for a moment.
Okay, cool. Okay, so is there a run task concept in HCP Packer where the process of creating an image, we can force a scan of the image being generated? So the current answer is it's not possible to force a scan at the image creation. The image metadata is pushed to HCP Packer at the end of the build, and once the image has already been created. And this is from one of our TAs as well, saying what I'm recommending to customers in the meantime is to run your scan as the last step of the build process. But that leaves the enforcement up to the person creating the image rather than it being forced across the organization. So that kind of makes sense. And yeah, let's move on and see what else we can get. So is it possible to revoke an iteration and enforce that revocation as permanent, i.e. no restore would be allowed? So short answer is no. Currently, that's not possible. Every revoked iteration can be restored by the user that is either a contributor or an admin. So there's different roles in there. It is possible to permanently delete an iteration both via UI and API, but that might not be the solution you're looking for in this case. The best way to address this is with RBAC using the roles that we have built in. And we're almost there by the looks of it, aren't we?
Yeah, it looks like we are moving a bit here.
Definitely.
Build finished.
Okay, one more question while we wait for that, which is there a way to fully remove a revoked iteration from HCP Packer? Short answer is yes. You can permanently delete iterations from both the UI and API. Deletion is possible from the iteration list also. And the iteration page as well. So yeah, that kind of covers that kind of area of revocation, which is, I guess, is a big thing for people. Is you build these things, when you revoke it, you want some confidence that it's fully revoked. So just understanding the parameters within that you're operating within is quite useful. So these are really good questions, and thank you to our TAs for providing pretty thorough answers to that.
Very much so. And one thing, maybe while we're on that topic, when it comes to iterations, we are actually going to do that later in the tutorial. We will be going through the scenario as if we needed to schedule a revocation for an iteration. And this is typically only done if an image poses a severe security risk, and you would need to revoke it to prevent consumers from accessing its metadata and using that to build artifacts. One thing that I'll point out here, since we're on that topic, though, is that you'll always want to make sure that a new iteration is available before you revoke an active iteration. When you revoke an active iteration, HCP will change the image ID attribute to error revoked, which can cause potential disruption of your downstream workflows. And I'll actually be doing that myself today, revoking that iteration without a new one in place. But this is for educational purposes of the tutorial, so we can see a run task failure. In a production environment, we always want to make sure that your channels are set to use unrevoked images. So this is just a demonstration. So always be sure that there is an active iteration there in place if you ever need to perform that revoke. Okay, so this will probably still take a few more minutes here, Rob, if we've got any more questions and answers there available for us.
Yeah, so we have some questions around integrations as well, which is always fun. So can we also register container images in HCP Packer registry in addition to machine images on AWS, Azure, and GCP? We have a short answer from our TAs there. I don't know if you wanted to chime in first or if you want me to go straight into that.
I think I'll let our experts from the TAs answer that one.
Awesome. So the Docker Packer plugin is HCP Packer ready, which means you can track Docker containers within HCP Packer, which is fantastic. It means that you've essentially, in terms of your images, whether it's VM images or whether it's container images, you kind of have a single repository, almost a single source of truth as to where you're going to pull these things from. So that's really, really good. We have another question here around cloud formation as well. So for some brownfield environments, this is where things always get tricky when it's brownfield because there are things that are beyond your control. So for some brownfield environments which are using cloud formation, can these types of patterns interact with HCP? And again, we have an answer from our TAs. So when we say brownfield, it's customers who are using CloudFormation for their provision, and I want to tell them to use HCP Packer. They may be thinking about moving into Terraform for their new environments and workflows, but still has to use CloudFormation because the tech debt and the investments that are involved, right? We don't actually have an answer for that. Do you have any kind of color to add to that?
I don't have anything. I would just, like you said, the brownfield environments are difficult because every situation is going to be entirely different. And I think in some of those cases, that might be worth engaging some of HashiCorp professional services teams that might be able to come in and help take a look at that environment and help make some more personalized recommendations for what that environment needs.
Absolutely. My good buddy, Adil, who I host the Keeping It Secure podcast with, is one of the people within HashiCorp that would look at things like this. So definitely reach out to us and we can put you in touch with the right people to have these kind of conversations to try and figure out what the best path forward is for you. Okay, we've still got time for more by looks of it. So yeah. Terraform Cloud. So the run task is referenced by a path that includes its SHA hash. And that's kind of the question there. It's more of a confirmation. And the answer we've got is in the run task path, there is a unique identifier that links the task back to a specific HCP Packer registry. Right? So that's kind of the relationship between the two. Let's see if we've got any more. So storing a commit. Does HCP Packer store your Git commit even if you designate your fingerprint separately? Short answer is no, it does not. HCP Packer stores your Git commit as the fingerprint, and if the custom fingerprint is set, then HCP Packer won't store it. You can still make HCP Packer store the Git commit by setting a build label with the value itself. We've got an example which potentially we can drop in the chat there. But that seems like it is perfect timing there. Managed to get through the question.
Yes, it is.
Just as Packer completed.
That build did take a little bit longer than normal, but we made it to the other side. So we're just going to keep on moving here to show our full example. So with our golden image built, I'm going to navigate back here to the HCP portal and create a production channel for it in the same way that we did for the Loki image. So clicking here and then channels, new channel, production, and select the latest iteration and our only iteration in this case to create channel. So with our golden image built and the production channel set for it, I can use it now as a base for our HashiCorp's image. Back in our terminal, I'm going to browse to the HashiCorp's directory. I'm going to copy one more fingerprint command. There we go, and initiate a Packer init and Packer build. So make sure that this build begins the way that we want it to, and then we can talk a little bit about the HashiCorp's code that we are building here. So if I bring my file browser up, I will collapse the golden directory and expand HashiCorp's. Okay, so a lot of this is going to be similar to what we've already looked at, but there's going to be a few differences. The conf.json file is a HashiCorp's configuration file that sets up the database connection, the bind address, and the metrics address. The docker compose.yaml is the configuration file used to start the application HashiCorp's with docker compose. Start-hashicorps.sh will actually run the docker compose command in the directory that contains the compose file above, and it will start the application. As we saw in the last images that we built earlier, HashiCorps.pkr.hcl is similar to the other Packer templates we've seen, but also contains extra blocks specific to HCP Packer. If I come here in line 15 to the HCP Packer iteration, we're providing the golden image bucket name and the production channel. That will inform this build to use the golden image that we built earlier as the base image for this one. And to get a specific AMI from a build iteration, I'm going to use the HCP Packer image data block and provide the bucket, iteration ID, which come from the HCP Packer iteration data object, the cloud provider, and the region. And the last two attributes are how I will differentiate between the multiple images published from a single build iteration. And the source AMI attribute is referencing the value retrieved by that HCP Packer image data object. So a couple other things to note here while we're still waiting. And this demonstration that we're going through will deploy, as we spoke of before, a Loki and Grafana instance. Your organization may already own your own deployment of Loki and Grafana maintained by someone on your team. If you want to use those instead of the demonstration instances that we're providing, you can definitely do that. You'll just need to update the docker daemon.json file and the promtail.yaml configs with the appropriate host IP when you actually go through and build that golden image like we did earlier. Okay, Rob, do we have any other questions and answers that have come through? This build shouldn't take as long as that last one we looked at, but we might have time for a few questions and answers here.
Let's take a look. See if we can find something relevant to what you've just shown, if possible. So we have a question about login, actually, which is interesting. So where should I see logs for failed builds? Can this be sent to Splunk or Loki? Again, we've got an answer from our TAs. It's a very good question, by the way, whoever asked that. When running Packer, there's a specific environment variable, which is all in capital letters, which is Packer_log. You want to set that environment variable to the number 1, and that will provide a more verbose log output. I don't know the answer right now for pushing those logs to Splunk or Loki, but I can figure it out and come back with an answer later on, is kind of what our TAs have said. So at least you can get that more verbose output there. And then we have this challenge of getting that output into our target platform, wherever it is that you want to track your logs there. So yeah, so we can do that. And we have another one here regarding failed builds. So what happens with the metadata in HCP Packer when the build fails? Again, another excellent question. It's a scenario that could happen. So good to know. A failed build can be rebuilt. So as soon as the build starts, HCP Packer knows a build is running and waits for its completion. If the build fails, Packer will use the iteration fingerprint to identify the incomplete build in HCP Packer and push the data when it builds successfully. Right? So essentially, even with the failed build, the metadata is still useful for future builds of the same image.
Great.
These are a lot of troubleshooting questions, actually. So we have a bucket with multiple builds. What happens if you refer to two different Packer templates to the same bucket? And the answer we've got here is HCP Packer does not prevent users to use two different Packer templates to build iterations of the same bucket. However, the bucket's iteration built out of a different Packer template won't correctly represent the incremental version of that bucket. And we consider this workflow an anti-pattern for building new versions of the same image. For two different Packer templates, we strongly recommend creating a bucket for each, right? And depending on how the HCP Packer registry block is configured, in the new Packer template, the previous bucket's information, such as description and labels, might get overwritten as well.
Got it.
Awesome.
That's some excellent information from our TAs. And it looks like our build has finished. So with our HashiCorp's image built, like we've done before with our other images, I'm going to browse back into HashiCorp's and create a production channel the same way like we did before. Production and B1, create this channel. So like we spoke of before, this is a good opportunity to test out our run test integrations. So here within our HCP HashiCorp's image, I'm going to click on iterations and then our single iteration and manage. And I'm going to choose revoke this iteration at a future date. This is the area that requires HCP Packer plus tier registry. And like we said, you've got free credits that are available to you that you can use to give this a try in your own environment. I'm going to set this in 1 minute time frame from now. Actually, got to make my screen just a teeny bit smaller so I can hit revoke. Okay, so it is set to be revoked in 1 minute. And we can see this take place. With all of those images built, our registry configurations and channel set, I can now deploy a HashiCorp's with Terraform. Before I run Terraform, I do need to update our two configuration files, main.tf and outputs.tf. I'm actually going to come down here and grab the configuration code from our tutorial. Come back here to Terraform, main, scrolling to the bottom, give it a space, and I'm going to paste that in and save it. Then a little bit further down, we have our outputs that I'm going to update our output. And we'll talk a little bit about that here in just a moment. At this point, I'm going to browse back into our Terraform directory and run Terraform apply-auto-approve. Okay. So we will wait to see what happens here, but very briefly, that additional code that I added to the main.tf file is responsible, as you can see here, at line 61. One configuration is going to deploy the AW instance HashiCorp's East. And the other resource is going to deploy another instance, HashiCorp West. These will be the images that are actually responsible for hosting our HashiCorp application that we can test out later. The outputs.tf, the additional configuration that I added there, is going to output the IP address of each one of those to the console as soon as the Terraform apply is complete. Okay. Uh-oh, it looks like our image revocation may have just been slightly out of sync with our revocation here. Let's see if it actually continues. I think it's going to. So I think I was just a little bit too quick. The timing didn't line quite up, but I can show you exactly what was going to happen. So our revocation was going to be set for 1 minute in the future. And when we had tried to apply Terraform at that point, our HCP run task would have failed because one of the images was being set in a revoked state. So if the run task had found a newer iteration, it actually would have suggested using it. And that's where we spoke of a little bit earlier, that we will always want to have a newer iteration available when we commit a run, so that something will be available for Terraform to use. In this case, though, it looks like we were just a little bit too quick and that revocation had not taken effect before we ran our Terraform apply. That's okay, though, because we are now at the point that we intended to arrive at with our Terraform configuration. Okay. So with the Terraform apply complete, I can see that the outputs and IP addresses of Loki and both HashiCorp instances. What I'm going to run now is a small curl command to test out our HashiCorp image and our application. So this curl, perfect, it already came back. So we have now served up a virtual coffee called Packer Spice Latte, which is packed with goodness to spice up your images. Perfect. So this tells us that HashiCorp is actually up and running. And now, since the golden image that we built contains all of the logging services and configurations, our HashiCorp images have automatically have their logs configured to be sent to Loki. All I now need to do is configure Loki as a data source in Grafana. I'll get the Grafana IP address from the Terraform output, and since it's running on the same instance as Loki, I'll use the Loki IP value. I can run this command to get that IP address and append the port for our use. This echo command here. Okay, there's our IP address and port. I'll go ahead and copy that, come back into Chrome and paste that into my browser. All right, and in the default setup of Grafana, the username and password are both admin. I will log in with those. I am going to skip changing that for now. Now, once logged in, I'll navigate to the settings and click on the data source option here. And I'm going to add a new source and choose the Loki template that's already available. Since Loki and Grafana are running on the same IP address, I can simply cop in what was already in my clipboard. But I'll need to change this to port 3100. Then if I scroll down and click on Save and Test, I can see that our data source is connected and our labels have been found. Once added, I will navigate to the Explore menu. Loki is already selected here at the top. And I'm going to click on this code button over here. And now we have a log browser. Well, I will choose some information about the logs we'd like to see. I'm going to choose Compose Service and then both API and Database. So if I click Show Logs, you can see that we've already got a group of logs that were generated as the instance and HashiCorp was created and started started running on the instance. At this point, I'm going to select live. And now if I come back into my terminal, we have a script that is available for us called HashiCorp's query.sh. And if I run this script, we will see that some coffees will start to be automatically ordered from the HashiCorp's application. And if I click back here within Grafana, so every time one of our coffees is generated and ordered from HashiCorp's, we can see that a relevant and applicable log for each one of those orders is seen in our live tail of Grafana. Perfect. It looks like everything is working exactly as we wanted to. So at this point, if I wanted to update the golden image, I could rebuild it with Packer and update the bucket channel to use the latest iteration. The next time I ran Packer build for the HashiCorp's image, Packer would automatically retrieve the newer golden image to use as the base. Similarly, if I did the same for HashiCorp's image and reran Terraform apply, Terraform would automatically retrieve the newer AMI and redeploy the instance with it. Now that we're done with this tutorial, I can clean up some of the resources I created. First thing I'm going to do, which we didn't get a chance to do it earlier, we can see that this iteration is in a revoked state. I'm going to just go ahead and click on that. It looks like I may have messed up a little bit my timing, but that's okay. We are going to come and it looks like it's still in a good state. So we're just going to proceed with cleaning up our Terraform resources. So canceling that script, I'm going to go ahead and run Terraform destroy-auto proof. That will start the process of cleaning up every one of these. One thing to note here, this Terraform destroy will actually destroy the image or the instance resources that were created, as well as the VPC groups and security groups. If you do this yourself, you will need to deregister the AMIs and delete the snapshots using them within AWS. That is not automatically done. Okay, perfect. So in this workshop, I went over using the HCP Packer registry to create a golden image pipeline that publishes AMIs to AWS. I also demonstrated how to integrate the registry into our image builds with Packer deployments with Terraform, allowing both tools to automatically retrieve the desired image ID without having to manually update templates or configurations. From here, you can integrate the pipeline with your source code repository and CI tool of choice to automate the build and publish process with the API. You can also use HCP Packer to simplify publishing and deploying golden images across your entire multi-cloud setup, since the build iteration can keep track of images across cloud services. So it looks like, Rob, we might have time for just a couple more questions here, if any more have come through before we wrap things up.
Yeah, we can add some clarification to some of the questions that were previously asked. The first question we had was how or why is HCP Packer usage different from using AMI regex in the AMI name and latest option in Terraform? The answer we've got here is HCP Packer lets platform administrators tag their AMIs with different stages of its lifecycle by assigning them to channels or other other than latest. In HCP Packer, the administrator also has centralized control over the same image built for different cloud providers. Using HCP Packer data sources to query an AMI helps platform administrators and consumers keep their infrastructure up to date and compliant, independent of their cloud provider, right? So it's a pretty compelling reason to centralize that, right? I think we're kind of in the realms where we're centralizing a lot of the components of our platforms and our stack. We're centralizing our identity, our secrets management. The same really is being done with our image creation and storage as well. We have another one here, which is, are there automation pipeline examples available for building images for KVM hypervisor with ISO plus scripts.
Hmm.
So the answer we've got here is each plugin has its own associated set of builders. For example, there are separate builders for EC2, VMware, VirtualBox, etc. If there is no official plugin from HashiCorp, there is a community plugin available. If not, you can create your own plugins as well, and you can leverage the post processes to create ISO images, right? So we have a link which will help give a bit more information about that, which I will get our wonderful TAs to drop in the chat. Let's see if we have anything else. Let's have a look. So we talked about revocation. We talked about image scanning and RBACs. I think that is it for questions. I think we have pretty much gone through everything that we have at the moment.
Perfect. That's pretty great timing here. We'll give just a minute or two back. I'd like to thank Rob for your help today on the presentation and our wonderful TAs for adding their expertise. So thank you very much for joining us today, and we hope you enjoy the rest of HashiCon.
Thank you so much.